Hello. The purpose of this video is to uh, explain via three examples how to complete the square for a quadratic in standard form when the leading coefficient is not 1. All the examples we've done so far, we have x squared plus something or other, but we haven't had a coefficient that is different than 1. So the process is relatively simple, but it involves a little bit of arithmetic and calculations. So please follow along, and I hope this helps. So imagine we have a function like this, f of x equals 2x squared plus 8x minus 7, and we want to complete the square for it. Needless to say, we know that the leading coefficient is 2. So what we do know is that we know how to complete squares for expressions that have a leading coefficient of 1. So we're going to benefit from that and rewrite this expression or this function with a factor of 2 and factoring partially the first two terms. So here's the key idea. We partial factor the leading coefficient from the first two terms. So in this case, you can see here that if I factor the 2 out of the 2x squared and the 8x, I end up with this expression, 2, and then in a bracket, x squared plus 4x, the negative 7 was unchanged. So now I can see that inside the bracket, I have an expression for which I can complete the square, like we have been doing. The only observation we have to make is this. We want to make sure that the expression on the bracket is the same. So now we need to rewrite this with an extra bracket, as it were, the 2, and then now this is the completion of the square that we have. X plus half of 4, 2 square, but then we need to subtract the square of 2 so that the x squared plus 4x is equivalent or is the same as this expression inside the square bracket. And then the negative 7 or the minus 7 that we've been carrying along. And basically, from here on in, we just expand the 2, applying distributive property, 2 multiplied by the bracket, 2 multiplied by the negative 8, to eliminate the square bracket, and then we simplify. So that's what these would look like. 2 times the bracket, the expression x plus 2 squared, minus 2 times negative 4 is negative 8, minus 7, and then we can just simplify the last two terms to negative 15, and that is the expression in vertex form. So 2x plus 2 squared minus 15, we know that the vertex is at negative 2 comma 15, and of course notice that the leading coefficient was unchanged. So I hope this was friendly. We're going to move to another example, and what happens relatively quickly when the coefficient is not 1 is that we end up with fractional expressions, but that doesn't really matter. Fractions are our friends. So let's look at this one, 2x squared plus x minus 3, the same process. The idea is the same. What is a bit, what we have to be mindful is the calculations, the arithmetic. But we're going to have here an area to that has a memo with a number of ideas that we're going to be connecting to help you with the arithmetic that is necessary. Okay, so we're going to partial factor the 2 from the first two terms, only the first two terms. Notice that the negative 3 we leave the same. So this is what happens when I factor 2 out of 2x squared plus x. This is what I get, this expression that we haven't read. X squared plus 1/2 of x. And I hope you can see that if I multiply 2 times 1/2, well, that's 1, which is x. So I factored it and I express it like this. So then I'm going to complete the square for this expression in red that is in the bracket. So I know my logic is that I take x plus half of 1/2. And just as a memo, half of 1/2 is equivalent to 1/2 multiplied by 1/2, which is 1/4. So that will give me this expression. Now notice that the next step, I'm adding this square bracket. So now I have the square bracket, because I'm completing the square for this expression in red, and I have x plus 1/4 square minus 1/16. Where did the 1/16 came from? Well, it was, remember, we had to subtract the square of 1/4. So 1/4 square is, when we square a fraction, we square both numerator and denominator. So 1 square over 4 square, which is 1/16. And just as a reference, we can see this. If we were completing our square from before, we would have 1/16 here from x plus 1/4 square. So we subtracted so that this expression in the square bracket is the same as the expression in red. So that's it. Now we are going to carry on, and we're going to expand by distributing the 2 to the first bracket and to the -16. And this is what our next step looks like. 2 multiplied by x plus 1/4 squared minus 2 multiplied by -1/16 is 2/16 minus 3. And if we need kind of to recall how to come to do this bit of fractional calculations, we can think about it this way. -2/16 minus 3 is the same as -1/8. 2/16 is 1/8, -1/8 minus, and I can express it 3 as a common, in a common denominator as the 8, which would be 24/8. So -24/8 is the same as 3 minus 1/8 is -25/8. And that is what is our expression with the square completed. And that's it. That tells us that the vertex is at -1/4 and -25/8. And that's it. The process is the same. We just have to be mindful of the arithmetic that is happening. The last example, similarly, we're going to have an area to help us out with the arithmetic to hopefully clarify everything. So here's our standard form: 4x squared plus 3x minus 5. We are going to partial factor this time the 4 from our first two terms. And when we do that, our bracket expression becomes x squared minus 3 divided by 4, because we factor the 4 out. So when we factor the 4 out, we have to divide by 4. That's really what we're doing. We divided the 4 for the 4x squared gives us 1. We divided 3x by 4, we end up with 3/4. And the negative and the -5 stays the same. So now I'm going to complete the square for this expression in the bracket. So I need to recall here that I need to do half of 3/4. So 1/2 of 3/4 is equivalent to 1/2 multiplied by 3/4, which is 3/8. So that is going to be our term inside the bracket. Now we go and we add this extra square bracket to make sure that this is clear. So I have the 4, and then the completion of the square inside the square bracket, x minus 3/8. But now I, of course, have to subtract the 3/8 squared. And just as a memo, when we square 3/8, we square numerator and denominator, and that is equivalent to 9/64, which is what we see here, and -5. Now we're going to distribute the 4 to our bracketed expression, and then we're going to multiply by -9/64, and this is what this looks like. So we're getting there. You can see here again that the leading coefficient maintains, and now I have x minus 3/8 squared, which is already in beginning of vertex form, and all I have to do is simplify these last two terms. And so just to help us with the calculations, when we multiply 4 by 9/64, I can easily see that I can divide both expressions by 4, and this is equivalent to 9/16. and then I'm going to do this calculation of negative 916 minus 5. And this time, I chose to do it this way. I can find the common denominator, which is 16, if I express 5 as, or negative 5 as negative 5, numerator in denominator 1, and I end up with this calculation that is negative 89 over 16. So at the end, my expansion looks like this. Yes, it has fractions, but hey, no problem. This is now the vertex form, and we have completed the square for this expression. The vertex is at 3/8 and negative 89/16. Of course, we can always verify all these in our Desmos graphing calculator. And I hope you followed, and thanks for watching.